Hi, in the previous video, we worked on building a molecule. We started off from building an atom. We went through the periodic table. This actually simulator covers the topic of atomic structure, isotopes, as well as periodic table, where you can have these multiple games and multiple build setups where you can explore these units while studying. You can use this app to, improve your understanding and learning process. Then we went on to this molecule building simulator where we tried to build several molecules, studied their three-dimensional structure, saw how they formed bonds, what type of bonds exist between different atoms, and then we covered few goals, and then we went into the playground and explored making some new type of molecules, discovered some molecules that we don't actually get to see or read in our books. So that's a fun way of learning about molecules, how they make bonds. Uh, Now we're moving on to the next part of our syllabus, which covers balancing equations after the structure of molecules, right? So let's begin. Okay, first we're going to introduce ourselves on how this actually works. We're going to see the graphs, right? So right now, this is one equation in which ammonia is being formed, right? And we want to start with one nitrogen molecule as well as one hydrogen molecule. Now, as you can see, uh, in nitrogen you have two atoms. So what is balancing? So let's get into the background. What is balancing? Now let's go through the lessons as well, along with our simulation, right? So when we have the problem of balancing equation, we want to understand that the number of atoms before the reaction, right, should be equal to uh, the number of atoms after the reaction. In this case, we have this diatomic molecule of hydrogen in this point, right, an oxygen atom at this point, which is also diatomic molecule. So we have two hydrogen atoms and two oxygen atoms, but on this side, at the product side, we have only two hydrogen atoms, which is the H2, and one oxygen atom, which doesn't satisfy uh, this balancing rule, right? That the number of atoms on this side should be equal to number of atoms on this side. So that's what we need to work on, right? So moving on, what we can do is add this 2 uh, at the beginning of this H, right? That makes hydrogen atoms being 4. Uh, we keep the number of oxygen atoms being 2 on this side, but over here we also add another 2 to multiply this 2 with this small 2 for the hydrogen and this O as well, right? So the 2 will be multiplied individually to both of these elements, and it would increase the number of atoms on this side of the equation. So in the products, now we have 4 hydrogen atoms. That makes it 2 into 2 makes 4, and 2 into 1, as there is no number over here, we consider it as 1. It would give us 2 oxygen atoms, making it a total of 6 atoms on this side and 6 atoms before the reaction. So this is how you balance an equation. So let's get back to our simulator, right? Uh, Before that, let's have some steps how we can make this process of balancing equation easier. So first, write a word equation, then put the formula for the elements or the compounds. Balance the equation, put the number in front of the reactants and the products when necessary. Complete the balance symbol equation using state symbols, right? So these are the 4 points that you need to remember before we go into uh, making any balancing problem, So uh, let's have magnesium, which reacts with oxygen to make magnesium oxide. So magnesium is a metal, oxygen is a non-metal, it's a gas, this is a solid. When we burn magnesium in air, it reacts with oxygen to give you magnesium oxide. So this is the word problem, step 1. Second step, convert a symbol, right, or the formula for these this word equation. So we have Mg for magnesium, O2 as oxygen is going to react in the form of gas when magnesium is burning, so it needs to be a diatomic molecule, while magnesium is a solid, so it needs to be in like atomic lattice form, right? And over here, when magnesium will react with oxygen, it will create an ionic compound, which is magnesium oxide, right? By the transfer of electrons between them, it's an ionic compound. So we have written this equation, and once we have written this equation, we're going to now uh, understand how many atoms are there. For magnesium we have 1. For oxygen, since it's a diatomic molecule, so there are 2 atoms making one complete molecule, so 2 oxygen atoms. But on this side, at the product side, we have only 1 molecule for 1 atom for magnesium, 1 for oxygen, right? uh, to balance this, we're going to add numbers to these to this equation. So to balance this, we're going to add 2 with magnesium to have 2 magnesium atoms on this side, and oxygen is already on 2, so we're also going to add this 2 over here to make yeah, this 2 and this 2 to balance this off. Now we have 2 magnesium, 2 oxygen on this side, so again 2 magnesium and 2 oxygen on this side, so this is balanced. But we still need to remember that we have to identify the state, the physical state of these compounds, right? For that, we're going to move on, and we're going to add S for solid, which is magnesium is a solid, it's a metal which is burning. Since it's burning in air, so we have oxygen in the form of a gas, and when they react, it forms a whitish compound. It's a salt, which is an ionic compound, magnesium oxide. It's also solid, right? So please remember these 4 steps. First, write the word equation, then write the symbol equation, balance that equation, and then write the states, right? So this is the perfect way of doing balancing process for any equation you want. Remember, this is very specific for IGCSE chemistry 0620 exam, because they will definitely deduct marks if you're not writing these states, or if you're not balanced properly, or when the question is asking you to specifically write the word equation first and then balance it off. So you have to understand that these 4 steps are very, very crucial, right? Okay, moving on. So we can have nitrogen reacting with hydrogen, giving you ammonia. Ammonia is also a compound which is a covalent compound. We have nitrogen as a gas, hydrogen as a gas, giving you ammonia, which is NH3. So we have written the formula. Now we know that there are 2 nitrogen on this side, 2 hydrogen on this side, while on the other side we have 1 nitrogen and 3 hydrogen in the form of ammonia. So this is not balanced. So what we're going to do is we're going to see how we can balance this, right? The easiest way is to add 2 to ammonia, making it 2 nitrogens and 6 hydrogens, because this 2 is going to get multiplied by this 3 as well, right? So to help that out, we're going to add 3 over here as well, right? So this is how we balanced it. So we have 2 nitrogen on this side along with 6 hydrogen reacting together to give you ammonia, which has 2 nitrogens and 6 hydrogens on this side, as there are 2 of these molecules, right? So 1 molecule of nitrogen reacting with 3 molecules of hydrogen, giving you just 2 molecules of hydrogen. So also let's declare the states. So nitrogen is a gas at room temperature, hydrogen is also a gas, and at room temperature ammonia would also be a gas, as even in the liquid form, if you just open up the container, it will start evaporating, because once in liquid state it evaporates very quickly at room temperature and converts itself into gas, right? So that's it for balancing equation. Let's get back to our PhET simulations and see what we're going to do with it, right? So here we are. Let's play this game in which we're supposed to be balancing equations, right? This is ammonia, the last reaction that we started off. This video with. So we're going to start with one nitrogen molecule, one hydrogen molecule, and we're going to get one ammonia. But is it balanced? No, it's not. As this says, this is not equal. That means we have two nitrogen atoms as nitrogen diatomic gas, two hydrogen atoms which is also diatomic gas. When they would react, they should give ammonia, but over here when we make one ammonia molecule, we have one nitrogen and three hydrogens, right? This is the molecule for ammonia. So to balance off nitrogen, we're going to increase the number over here, 2. So we have now 2 of these blue nitrogen atoms, but consequently we have 6 of these hydrogen atoms over here. So we're going to increase the number of hydrogen over here, and there we go, voila, it's balanced. So this is how you can balance equations. So we can have 3 other variants where water is being separated using electrolysis or any other process. So if we have one molecule for water, we can try and balance it out as quickly as possible to match these two oxygen atoms. I'm going to increase the number of water molecules over here. As you can see on the top, it's giving the stats as well. So there we go, balanced. Next one, methane burning. It's the gas that we use in the stoves. CH4, we have one methane molecule burning with one oxygen, giving carbon dioxide and water. Now here's the problem, we have 2 oxygen over here but 3 on this side, so we're going to try and increase the number of oxygen on this side. Now we have 4 here but 3 here, let's increase more. So voila, balanced, right? 1 carbon, 4 hydrogens and 4 oxygens, balanced on both sides, right? So you can use this. This is just the introduction to this simulation. Now we can go into the game where we have different levels to identify these molecules. We can also use the timer if you want to gauge yourself how good you are doing, right? So level 1, we have this, we have timer going on. So we have phosphorus, pH 4, reacting with hydrogen to give you pH 3, which is another covalent compound, right? So we have to reduce 2 of these to get 6 of these, and we have P4. So in other words, we need to get 4 of these phosphorus, and 1 2 3 4 5 6 7, this is 12 of these, 1 2 3 4 5 6. So check, this is correct. Let's go. Next one, SO3. This is SO3. So let's see, I think we have more oxygen on this side, so we need to increase more. So 2 of these, so giving us 6 of these, I think this is correct, right? Moving on, ammonia. It's very simple. We got 2 of these ammonia, and there you go, done. HCl, right? Well, that's hard. So okay, there we go, carbon monoxide. That's gonna be tricky. Okay, we have 2 carbon. I think that doesn't. So there you go. You can try different levels. I'm going to try all of them in a quick succession. So play this game. It will definitely improve your understanding of how you're supposed to be writing equations in your paper. If you practice this at least once in a week, play this game around, I think you're going to do very well in writing equations in the paper. You will be very confident at solving the paper. Let's see, oxygen, yeah. I'm more immersed in the game at the moment. So we've got 6, that's done. Okay, next one. Okay, just look at how the colors are there and see what you can do about it. So we have 2 carbon, so we need to have 2 carbon. We've got 4 oxygen. Let's make it 6 because we have to have even number, right? 6, yeah, 6 4, I think that's done. Okay, that's a 2 1. Just simply add 1 of these and see what we need to do. So 1 brown, 1 oxygen, we need to have 2 of these reds to at least get one of this. So at least put it to 1 so that you know what you're supposed to be balancing with, right? Now 2 oxygens for these. I think that's done. Next, CH4, S, CS, CS, H2S. Oh, we need to have 3 of these sulfur molecules, right? Uh, okay, 4 hydrogens, 1 carbon, 4 of these, done. So yeah, there you go. HF, we need to have 2 HF, 2 hydrogen, 2. Okay. Okay, we can do this. That's gonna be a tough one. Okay. I'll give 4 oxygen, and I think that's wrong. Not simplified. Balanced but not simplified. Okay, that means it is balanced, but I could have gone for a less number of molecules, right? So let's try again. Let's see if we can reduce by this, I guess. Oh, it was balanced like this. Oh, okay, we got 9 out of 10. Pretty close. Okay, this is level 3 now. Let's see what difficulty do we have over here. We've got 4 of the oxygen, right? Now 1 carbon. Okay, we need to have more oxygen from here. Okay, 1 carbon. Let's start with 1 over again. This is difficult actually. Let's see. We have 2 of these. 2 of these, 2 of these. Okay, we need to increase this carbon dioxide. Now we have 4 oxygen. We'll balance oxygen later. So if there are 2 of these, then definitely okay. 5. Okay. One, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we need to have 5 of these. Okay, well that was hard. Okay, that's good. Let's see what we can come up with. So nitrogen, we got 2 nitrogens, 1 oxygen, 2, but hydrogen is not balanced. So we're going to have this to balance hydrogen, 6 hydrogen, 6 hydrogen over here. Now we have 3 nitrogen, that's kind of odd. So we're going to have 3 of these, 1, 2, and 3 oxygens, right? Okay. Nitrogen. Okay, how many nitrogen? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to go to 5 of this. How many oxygen do we have? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now our hydrogens 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12. So we have this. I think that's balanced. Oh, wow, that's harsh. Okay, let's continue. Let's see if we can finish this up quickly. Okay, so we have so we need to balance ammonia. 6 hydrogens, 2 nitrogen, 2 nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. Okay, so that's also the problem. We're going to go to 6 of these, 4 of these, 4 of these, and 4 of these. So how many hydrogens, oxygen do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 of these. So we're going to go to 7 of these, right? Now we have 1, 2, 3, 4, 4 nitrogens and total of 12 hydrogens. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So done. Okay. always check, just count how many of these are there. So we have 2 carbons and 3 oxygens. So hydrogen we have 1 2 3 6. So to balance 6 we're going to get to 6 of these. So I think that does it. So 1 2 3 4 2 carbons, 2 carbons, hydrogens, 6 hydrogens, 1 2 3 4 5 6 7 7 of the I think that's done. Next, let's put 1 2 carbons, so 2 carbons. Now we have 5 of the how many hydrogens are the 6? 6. So we've got 1 2 3 4 5 6 7. Now 7. Now 1 2 3 4 5 6 7 8 9 10 11 12 12. So we can get 2 of these. We get to have 4 of these. So we have 1 2 3 4 5 6 7 8 9 10 11 12 13 14 14. So I just need to raise it to 7, and that should be it. Okay, that's it for the balancing equation. Do play this game. Do share the results if you have any difficulty in understanding how to balance equations, or if you have any suggestions, please put it in the comment section. I'll try to get back to you as soon as possible. Thank you so much. Bye bye.